The five types of generic slab track system are embedded rail, booted sleepers, resilient base plates, casing sleepers, and floating slab. Embedded rail is that the rail sits on the resilient pad and is held tightly by wedges and shims made from elastomeric compound. There is a PVC tube attached to the system to reduce the volume of elastomeric compound and provide heat to remain its neutral temperature. Embedded rail shows a very elegant solution for track fastening systems, and if integrated into concrete subslab, it can prove a very cost-effective and innovative invention. Booted sleepers is that the rail is mounted on a twin block concrete sleeper, which is wrapped with resilient boots recessed into a concrete slab. The sleeper block sits on an elastomeric pad and is surrounded by house, which means the boot. Therefore, the elasticity is provided by the rail pad and the resilient pad beneath the rail. This system is used mainly in tunnel constructions. The problem it has is that the ingress of water. Since the structure is complicated, tiny spaces occur between each part. With these spaces, water can penetrate between boot, sleepers, and the concrete surround. Of all kinds of damages, water ingression is the most unlikely to be noticed, but the most dangerous one. It will cause the wear and the deterioration of the concrete surfaces and affect the stability of the rail. The only solution now is to put polyurethane on the surfaces to avoid water ingression, which can be another extra cost. Resilient base plates is that the rail is attached to a concrete slab by means of base plate containing resilient pad. Direct fixing to the base plate has been used throughout the world as a system to reduce dead weight. Within the base plate are a rail pad and a resilient pad to provide elasticity. Casing sleepers is that the rail is mounted on a sleeper by means of resilient base plate. The sleeper is cased into a concrete track slab. The base slab or trough section is slip-formed. Track panels with the rail mounted on the sleepers are then set up, while longitudinal reinforcement and additional lateral reinforcement is placed. Preliminary adjustment for line and level can be carried out by screwing through the sleepers to hold the track in position. Final adjustment is carried out by hand prior to concrete placement. Concrete is placed between the sleepers and finished by hand. Good compaction of concrete beneath the sleepers must be ensured. Floating slab is that the rail is mounted on the concrete track slab, supported by a resilient layer or spring system. The choice of system usually depends on cost and the acoustic performance. Compared to other slab track systems, floating slabs generally require greater construction depth. Generally, switches are designed to be safely traversed at low speed. However, it is possible to modify the simpler types of switch to allow trains to pass at high speed. More complicated systems, such as double sleeves, are restricted to low-speed operation. The conventional way to increase turnout speed is to lengthen the turnout and use a shallower frog angle. If the frog angle is so shallow that a fixed frog cannot support a train's wheels, a swing nose crosses will be used. Higher speeds are possible without lengthening the turnout by using uniformly curved rail and a very low entry angle. Track maintenance. Track needs regular maintenance to remain in good order, especially when high-speed trains are involved. Inadequate maintenance may lead to a slow order, which means a speed restriction. Track irregularity can be caused by frequent passage, heavy load, and vibration. And the reason we need to handle it very carefully is because of the safety, ride quality, noise, and the vibration. There are two kinds of track irregularity: long wave track irregularity and short wave track irregularity. Long wave track irregularity is a slow change in track irregularity over a long span. It mainly makes the passenger uncomfortable. Short wave track irregularity is rail surface irregularity. It is shock and high frequency vibration between rail and wheel, so it can increase load on track, noise, and vibration. As you can see on the picture, the long wave track irregularity mainly affect the body, while the short wave track irregularity affect the wheels. So to find the irregularity, we must perform some inspection. In the early days, the track inspection is performed by manual labor, which is very dangerous and inefficient. So today we use inspection cars instead to save time and labor. Data stored can be used to analyze degradation of the track and pinpoint and predict trouble spots. The inspection cars can get data like parameter measured, alignment, cross level, curvature, rail gauge, and rail profile. The picture you see on the right is Dr. Yellow. Dr. Yellow is high-speed test trains that are used on Japanese Shinkansen. After we find the irregularity, we must do some treatment, and we perform the track irregularity control by rail grinder. It can grind out rail surface irregularities, reducing vibration and noise. The picture you see is from Taiwan, Jiayi. This is the end of the report. Thank you for watching.